Hello, I should be talking about performance of coated cutting tools in machining. This is the paper that is written with collaboration with my colleagues Srikant and Vamsi. As you already know, machining is a major stakeholder in the economy and contributes to about 5% of GDP, world GDP. And many a times machining is limited by the downtimes that are experienced and large setup times that are involved. And as the machining proceeds, tool wear generally contributes to a deterioration of the quality as well as the productivity. Therefore, it is very important that cutting tools should be chosen appropriately to improve the efficiency of a given process. Now, as you already know, cutting tools lose their properties at high cutting temperatures. And high cutting temperatures come because of the interaction of the tool with the tool material with the cutting to workpiece material. Now, accelerated tool wear at high temperatures that normally contributes to the plastic deformation of the tool tip, and that also sometimes caused by the diffusion of the binder material that is present in the cutting tool material. Since temperatures depend on cutting speeds, to get higher productivity, it is often necessary to develop cutting tool materials that are resistant to higher temperatures. Now, historically, a large number of cutting tool materials have been developed, starting with the early 20th century high-speed steel to the other materials as good as diamond and CBN, ceramics and carbides. Of all these materials, because of the better hardness and toughness combinations, the carbides are one of the most extensively used tool materials in the industrial scenario, so that contributes to carbides and coated carbides. As you can see, the range of coated carbides is much better than either carbides or ceramides. uh, Visually, you can see that coated carbides have the color, whereas the uncoated carbides do not have any color that you can associate with them. Now, carbide can be, the coatings can be either mono layer, such as titanium nitride that you see most of the ones which is widely used, or you can have multi-layer coatings that also will be present, titanium aluminum nitride or titanium carbonitride, etc. These are some of the systems that have been developed. Now, one of the most important part to be considered is that coating techniques influence the performance of the tools. So the two coating techniques that are generally used are chemical vapor deposition and the physical vapor deposition. So titanium nitride is one of the most common application. It can be done with both the PVD as well as the CVD. And what has been noticed is that monolayer can be applied on carbides. For example, as we can see here, the uh, normal carbide with 6% of cobalt binder, that is the traditional carbide. So strength and hardness have been improved, and they consequently they provide with higher tool life. You can also provide nano layers with best adhesions and wear resistance and longer life. So by you can also add by nano layer resistance to cohesive and adhesive failure, because these contribute to lower built-up edge. But multi-layer coatings, uh, what will happen is that adhesion will get improved, particularly if you have a harder substrates. So the intermediate layer helps in the adhesion of the coatings. And generally, the substrate should have lower residual stresses, Otherwise, the tribological properties of the coatings are likely to be affected by the elastic plastic deformation of the substrate. So that should be avoided. And one of the major limitations of these multi-layer coatings are the delamination. So we need to look at them. So these are some of the coatings: aluminum, chromium, silicon nitride, and titanium, aluminum, silicon nitride coatings, generally done using PVD technique, physical vapor deposition, and they contribute to high wear resistance. And but again, the same problem of delamination comes, particularly when you deal with the substrate which has extremely smooth substrate. So it will have to be uh, also, sometimes it has been noticed with multi-layer coatings such as these resulted in higher surface roughness of the machined components. Now, carbon nanotube coatings, because carbon nanotubes are having extremely high strength, and therefore normally these are applied on diamond tools using electroplating process, and it has been noticed that the tool life of the CNT coated diamond tools is 8 times that of uncoated tools. So some of the applications like titanium carbonitride, substrate is a titanium material with cemented carbide tool using high temperature CVD process. Uh, Nitrided and carbidized, high micro hardness, delamination don't take place, and highest room temperature hardness improves adhesion. The performance wise, it increases tool life and crater wear. These are some other coatings, and unfortunately the time given to me, 10 minutes, does not allow me to go into the details, but you can notice that these have improved the wear resistance and higher tool life, and generally delamination still is a problem that one has to consider. Higher tool life. So most of these coatings have higher tool life, and generally they are with a low built-up edge phenomena, and also they will provide you with higher tool life. Typically tool lives of coated tools is almost 3 times to more, but also of course the cost is equally higher. So cutting tools, as we said, lose their properties at higher temperatures. Coatings are effective in enhancing the performance of the cutting tools. That means they have lower tool wear rate and better dimensional accuracy, and then higher tool life. So instead of single layer, multi-layer coatings are quite extensively used, because the multi-layer coatings allow for the use of carbides for a much larger range compared to a single layer ones, and therefore normally these are preferred to, so that they will reduce the inventory of the organizations. Tool life improvements and better thermal resistance are reported for practically all carbide tools. For titanium aluminum nitride coatings, delamination is a major limitation. So anytime when the delamination becomes a problem, we need to be very careful with the choice of the substrate and substrate's performance. So these are a few of the references. The more details are given in the um, paper. Thank you.